Welcome back everyone. In previous video we laid down the foundational overview of Python, what it is, why it dominates in modern software development and how it works under the hood. As a part of my CDP, I'm making this complete hands-on series to take you guys step by step from a beginner fundamental to a real world software architecture. Today we kick off our first coding lesson, our lecture number second, variable and data types. Before we write a code, we need to understand what programming actually is. At its core, a computer is just a collection of electronic components that only understand two states, electrical current flowing or no current flowing. We represent this as 1 and 0, also known as binary or machine language. Imagine you travel to a foreign country where you don't speak the local language. To communicate, you hire a translator. Programming works exactly the same way. Human cannot efficiently write millions of ones and zeros. Instead, we write in high-level languages like Python, which reads almost like plain English. Python uses a built-in software tool called an interpreter. The interpreter acts as our live translator. It reads our Python code line by line, translate it instantly into machine language, zeros and ones, and hand it to the computer's processor to execute. This means your only job is to learn the rules of Python. The interpreter handles the hardware communication for you. Let's discuss our first foundational concept, variables. The easiest way to visualize a variable is as a labeled storage box inside your computer's random access memory. When you create a variable, you are telling the computer, hey, set aside a small piece of memory, put this specific value inside it, and slap this label on the front so I can find it later. Let's look at how we write this in Python. Notice the syntax here. In standard mathematics, the equal sign means both sides are perfectly identical. But in programming, the symbol is called assignment operator. It means take the value on the right hand side and inject it inside the storage box on the left hand side. Python is incredibly smart. It is a dynamically typed language. This means you don't have to tell Python what kind of box you are making. It looks at the value you provide and figure out the box type automatically. We can actually see where the computer hides these boxes using a built-in tool called ID, which shows the exact memory address of the variable. First, let's run this code and look at the output here. We get the output, Alice 19 and balance is 250.75. Now here we can uh, here ID is used. Here ID is a built-in tool to show the exact memory address of the variable. Let me show you the example. Here, a random number is generated, but this is not a random number. This is the memory location of username. Before we move on, first, before we move on, you must follow strict naming rules or your code will crash. First, no space allowed. You cannot name a variable user space name is equals to 19. Instead, use an underscore, user underscore age. This style is called snake underscore case. Second, start with letters. A variable name must start with a letter or an underscore. It can never start with a number. For example, first place first underscore place is illegal. Place underscore one is legal because you cannot start a name with a number. Third, case sensitivity. Python treats lowercase and uppercase letters as completely different boxes. Just like you wouldn't store milk in a cardboard shoebox, a computer cannot store text data the same way it stores numbers. We use data types to tell the computer what operations can be performed on a specific variable. Let's break down the four pillars of basic data types. First is string. String represent textual data. Any sequence of characters wrapped inside single quotes or double quotes is treated as a string. Let's take an example. First, let's make a different file named data types .py. Okay, so now let's look at the example of string. First, let's make a variable and then we put the value inside it. Welcome to Python. Type is also a built-in function which is used to get the type of the variable or the value inside it. Let's print this. Here Here you get the class str, which means the value inside the variable name mess is a string. Now let's look at integer. Integer represents whole number without any decimal points. They can be positive, negative, or zero. Let's look at the example. Let's name a variable score. Let's say the negative. Let's print this. Let's comment it out, and let's print the here. It has given the class int, which means the item in cost, which is an integer. Int is used for integer. Now let's look at the boolean. No, first let's look at the float. Floats represent real numbers that contains a decimal point. You use these for precise measurements like price, GPA, or coordinates. Let's look at the example of this. Here we get the type float, class float, which means the item value is of floating type. Now let's look at the last type, which is a Boolean type. Boolean represents logic. A Boolean variable can only hold one of the two possible values, true or false. Note that the T and the F must be always be capitalized. Let's look at the example. Here, name a variable. You cannot name it N. Let's name a variable A and so it's equals to current the type of this. Explain the type of B. Here it is shown bool, which is a boolean type. Bool is used for the boolean type. Let's look at the type of A also. Look at this. Here the compiler gave us two bools, which means both are of boolean type. Let's comment this out. We also have a fifth type, which is not mentioned here. No, it is not mentioned. It is of none type. Sometimes you want to create a variable box, but you don't have a value for it yet. For this Python, Python uses none, which signifies the absolute absence of value. Let me show you the example. Future data. None. This is also a data type. Let's comment this out. Static programs are boring. To make our application dynamic, we need to accept data from the person using our software. Python gives us a clean way to do this using the input function. Let's write a quick program to ask a user for their details. So guys, basically my VS Code is not working right now, so I'm gonna use the online Python compiler. You can also use this, but in VS Code you can save your programs so that so that later on you can revise them. So let's take a variable called name and input our name, enter, enter name, and let's print this hello, hello name. Welcome, welcome to class. Let's run this code. Let's enter my name. My name is Ansh. Hello Ansh, welcome to class. So this is how the input function works. Now let's look at a massive trap that almost every beginner falls into. Let's try to build a simple application that asks for a birth year and calculate an age. Let's write a code. Enter birth year. Age will be 2026 minus birth year. Let's print our value. Print age. Let's enter birth year 2007. Look at the terminal screen right now. The program crashed with a severe error, type error. Why did this happen? The rule in Python is simple. The input function always captures data as a string, also called text. No matter what the user types, even if the user types 2005, Python reads it as the text string 2005. You cannot subtract text from a number. To fix this, we must use typecasting to manually force Python to convert that string into an integer. Let's rewrite our code. Birth year, birth year as string. Let's take birth year string is equals to input, enter my spelling, enter birth year. Let's take birth year numeric. Let's convert the string into integer. What's the string? Okay. Now current year is 2026 and calculated calculated age will be current year minus birth year birth year numeric. Let's print the result. Calculated age. Here we have to enter our birth year 2007 and here the age is calculated as 90. As we learn to As you learn to code, you will run into errors constantly. Don't be discouraged. Debugging is 80% of developers' daily job. Let's learn how to read a Python error message known as a traceback. If you make a typo, such as calling a variable that doesn't exist, as you learn to code, you will run into errors constantly. Don't be discouraged. Debugging is 80% of developers' daily job. Let's learn how to read a Python error message known as a traceback. If you make a typo, such as calling a variable that doesn't exist, Python will throw a name error. Let me give an example of that. My score is equals to 100 and print this. Let's print this my score. Look at the bottom of the line. It says name error. It also gives you the exact line number where the issue occurred. Line number 2. When your program breaks, don't panic. Read the very last line of the error message first. It will tell you exactly what went wrong and where to fix. Here, it has also given us a hint called my score. Let's fix this. A variable name is my score. At the last, it is not double E. It is single E. There is a spelling error. Now let's look at this. The code is run. Now that we have covered the theory of variables, data types, and inputs, it's time to apply what we have learned. We are going to build four real world mini programs together. Whenever you tackle a programming problem, I want you to use a secret developmental model called IPO model. IPO stands for input, process, and output. Every piece of software on earth, from a simple calculator to a massive video game, follows this exact loop. It takes an input from the user, processes it using maths or logic, and produces a useful output on the screen. Let's start with our first challenge, the restaurant bill and tip calculator. The real world scenario. Imagine you are sitting at a cafe, the waiter brings you a bill and you want to calculate how much tip to leave and find the final total. Let's break this down using the IPO model first. Input. We need to ask the user for two things: the original bill amount and the percentage they want you to tip. Process: we will calculate the tip amount by multiplying the bill by the percentage. Then we add that tip to the original bill. Now, at last output, we will print a clean, readable receipt on the screen. Let's write our code. This is our first problem. So first we will take an input of base bill. Base will be float. Total. Enter the total. Bill. Next we will input our tip amount. Tip amount. Notice that I have wrapped input function inside float because money isn't always around. Whole numbers like 10 or 20, it can be 15.50 or 22.75. By using float, we can tell Python to treat these inputs as numbers with decimal points. Now let's handle the process. We have to write the logic now. Logic will be tip amount. Tip amount is equals to base bill. Base bill into tip percent, where we have a mistake. We have to write percent. Divided by 100. Now we have to calculate the final amount. Final amount will be base bill. Base bill plus tip amount. On the fifth line, we've calculated the absolute tip amount if the bill is 100 and the tip is 15%. This formula calculates 100 into 0.15, which gives us $15. Then on line 6, we will create a new variable box called final total and add the original bill to the tip. Here we have to write total. Now let's print the output. Base bill print the tip amount and print the final bill. Let's run this. Let's enter bill. Suppose bill is 100. Tip percentage, tip will give 15%, and the output is 115. So when we run this, Python neatly piece together our text message with one numeric variable. We have tested out. Now let's move to our second problem. Our second challenge is a metric converter. The real world scenario. Let's take a real world scenario. Imagine you are road tripping in a foreign country. The road signs are in kilometers, but your car dashboard only show miles. We want a program where we can type in kilometers or get miles back. Now let's look at the IPO model for this. Input will be the distance in kilometers. Process will be to convert kilograms to miles. We multiply the kilograms by a fixed conversion factor, which is 0.621, and the output will be the converted distance in miles. Now let's code this problem. This is the first problem. You can note this down. I'm going to use this. Now our second problem, we have to take input. Input will be in float and enter distance in kilometers. Now let's apply the logic here, the process according to the IPO model. Process will be conversion factor. Conversion factor is equals to 0.6. You can Google this. Conversion factor is 0.621371, and let's calculate miles output. Mile output will be kilometer input into conversion factor. This is the logic, the also called process according to IPO model. Let's print the final answer, kilometer input kilometer is equal to miles output. Let's print this out. First, let's understand what we have written. Look at the line 5. I created a variable named conversion factor, even though we could just write the numbers directly in our math. Creating a variable which with a descriptive name makes our code much easier to read for other developers. When we run this code, we can input only kilometer values, says 10 kilometers, and Python multiplies it by our conversion factor to output approximately 6.21 miles. It's like a custom built translation machine for physical units. Let's run this. Suppose 10 kilometers, 10 kilometers, and look at the answer. 6.10 kilometers is equal to 6.21371 miles. This is our second problem. We have done this, and now let's move to the third problem. For our third problem, we will build a grade averaging engine. The real world scenario is at the end of the semester, your professor wants to find your average score across your 3 major exams. Now let's analyze this using IPO model. Input: 3 separate test score from the students. Process: we will add all 3 scores together and divided the sum by 3, and the output is the single average score. This is a very easy code. You can do this by yourself. But let's write the code. Now we have to take 3 inputs: score 1, score 2, score 3. S1 S1 is equals to N. Let's take this in float. Into your marks, into your score. Uh, you can do this by Alt Shift and down button. Score S3 and S2. Let's calculate the average now. The logic average score is equals to score S1 plus S2 plus S3 divided by 3. Let's print the output. Average score average score is score 1 is 50, 70 and 90. Our average is 70. Now let's this is a very easy code you can understand by yourself. You have to take three inputs and the logic is average. You know how to calculate the average, and at the end we have just print the average score. Now let's move to our fourth problem. Logic test flags. This is the final challenge. The real world scenario. Think of a portal where students log in to see if they pass their exams. The passing marks is 50. The computer needs to look at the marks and stamp the profiles with a simple pass or fail. Let's map it out using the IPO model again. The student input will be the student's numerical score from 0 to 100. And the process, we will compare the scores to a passing threshold of 50. We want to ask uh, the computer if is the score greater than or equal to 50. The output will be a boolean value, true if they passed and false if they didn't. Let's build this. First we'll clear the output. The input will be student marks is equals to input. Enter the numerical marks 0 to 100. Our logic will be passing threshold 50. Passing marks is 50 and has passed student marks is greater than or equals to passing marks. Let's print the output. That the students successfully passed the exam. Now let's print the output. has passed. First, let me explain the code. Now, notice how we use the greater equal to operator on line 4. This is called a relational operator. It compares the value inside student marks against our passing threshold of 50. Because this is a logical comparison, the result store inside has passed is not a number or text. It is a boolean, true or false. If you type in 78, the output prints true. If you type 42, the output prints false. This is exactly how automated systems make decisions behind the scenes. So let me run this code. First, we will input 78. Did the There is a spelling mistake. Let's run this again. 78. Did the student successfully pass the exam? True. Yes, passed the exam. And let me input a number with a small letter. False. You can see the output. The code is working. These are the four codes which I have to explain. These are the four problems. You can do it by yourself also. There are many problems on Google. You can use ChatGPT. There are so many problems on internet which you can solve by yourself. And that brings us to the end of lecture 1. Today we covered a lot of fundamental ground. We looked under the hood of computer memory to see how variables act as strong boxes. We learned how Python uses data types to categorize text, whole numbers, decimals, and logic flags. We broke the beginner trap of the input function using typecasting, and we applied the IPO model to solve four practical programming problems. Remember, programming is a hands-on skill. Don't just watch this video, open up your editor, type out these four practice programs yourself, break the code, read the errors, and fix them. That is how real software engineers learn. In our next session, we will take our code to the next level by teaching it how to make decisions using conditional logics. Thank you so much for watching. Keep practicing, and I will see you in the next lecture.